Good morning, everybody. Good to see everybody. So we'll jump right into a little data science, a little manufacturing over your coffee in the morning. So really three things that I want to convey to you. So to make sure you have a good perspective on this thing that people call smart manufacturing, IoT, a little bit of how we're enabling data analytics in the factory, but really that means bringing together the things that historically manufacturers have done in terms of real-time feedback control, and then statistical process control. So two techniques that collect a lot of data at different timescales. One of the opportunities with data science is to sort of start to merge those things. And then finally, there's a lot of data in the manufacturing enterprise. There's a lot of people that understand manufacturing. There aren't as many people that understand data. So the last thing I'll leave you with is an approach called homomorphic encryption. It's an encryption technology that allows us to, as you'll see, maybe enable some new business models where it's a little bit easier to outsource your data science if you're a small and medium enterprise, or you don't have necessarily the data science expertise in-house. Okay, so that's the summary, but let's go see some of the details real quick. So the context, you can't sort of be in manufacturing today without realizing you have a lot of data. There's a lot of opportunity to make better use of that data. It's the proliferation of sensors, the proliferation of better communication. So our focus is the application, applied AI and machine learning, applied data science to the manufacturing enterprise. All right, so a lot of times I spend working with companies that trying to understand this smart manufacturing thing. I say, listen, it's really the things you've been doing. You've been doing process control, you've been collecting data, you've been doing quality control. It's really advanced and applied measurement science. And it's the things you do as manufacturers already, but you can do it faster, bigger, and better. Always having the manufacturing context. Sort of the subtext for why I'm here, it's the same reason why I was in Italy last week. It's the same reason that I'm flying to India tonight. So these techniques that we're going to be talking about are applicable broadly across many manufacturing enterprises. So we were applying in fiber manufacturing and coffee roasting, and as you'll see, also working at engine manufacturing. So measurement science now in manufacturing. To oversimplify, on the one half of the world, you have timescales around seconds or sub-seconds where you're doing real-time feedback control. You have something you're measuring, a thing you're trying to monitor and control, and you're applying control action to try to make sure that your machine is maintaining that steady state. After you deal with the deterministic sources of variation, then on the SPC, the statistical process side of the world, you're basically monitoring, is your world look normal? Is sort of the variation that remains sort of Gaussian distributed, and you're just tracking trends. And that works fine. But we're trying to break that paradigm, so to bring that together a little bit, to allow the statistics that you're collecting, the big data that you typically are looking for to be normal. The world is not always normal, but let's look at these opportunities where we're blurring the lines between the things that are statistically significant and the things we're trying to do in real time. So one quick case study. So this is the first place where we applied at the edge, meaning sort of on the line, your computing power, machine learning, not in somebody's cloud, but on the manufacturing floor, with the application towards fiber control. And fiber is a complex process where we're controlling heat and temperature and speeds. And really what we did is take the framework of deep reinforcement learning. And inside of deep reinforcement learning, there are pieces that look like conventional feedback control, where you're collecting some data, you're determining, well, what's different than what you want, and applying some control action, some update. And that piece that I'm circling in blue is sort of within the deep reinforcement learning framework, sort of things that you could call looking like real-time feedback control. And then everything else is collecting the data, the long-term trends. And so we're able to evolve and learn models of the process, learn models of how the machine is wearing or how material is varying. And so the paper that we put out that's led to a ridiculous amount of work, and quite frankly, been sort of pulled into the fact that we have to start a company in this space, is sort of the application of deep reinforcement learning to improving process control. It looks, in many ways, things that you would do with model predictive control and other ways to evolve your models and evolve your controllers. But machine learning frameworks provide a nice sort of coherent framework in a way to do this that other techniques have not. So that's sort of thing one. So in this way, we're really trying to blur together the lines. The summary here is merging together the things that are done in real-time feedback control and statistical process control in a coherent framework with applied machine learning. The next piece I'll just touch on then is if you're a small and medium enterprise, you're going to understand your process. You may not have the resources to invest in the new data science folks that you need to take better use of your data. Or if even you're a large enterprise, you may not be able to find the people to take over your data science needs. So we've been looking a lot like how do we enable sort of new models, new business models for data science. And originally this work was in part sponsored by Deshpande through EMA, one of the corporate sponsors. This piece was funded by Liberty Mutual as an insurance provider, trying to figure out what's the business model for insurance providers in the data science space. Can they provide some of the third-party in-between services? You're a manufacturer, you're somebody that understands data science. Can they be the arbiter of the people that manage the data and provide some of the infrastructure? So that's sort of an evolving piece, but I'll share the technology. So this is a paper you can look at that sort of explains a little bit about how we apply homomorphic encryption to preventative health maintenance. But in particular, just what is it? There we go. So we'll talk sort of briefly fiber extrusion, where you sort of make this fiber. But the key piece is that we have a piece of rotating machinery. Many places where rotating machinery matters, where you have a bearing that is wearing, a bearing lubricants that are running out. And so one of the things you'll care about in a manufacturing enterprise is, do you start to see vibration on machines that are starting to wear? So just a sort of a cartoon here. If you have this spindle that's rotating and it's well balanced, and I'm rotating a spool of fiber, when it's brand new across the top, depending on the speed that I'm spinning at, I'm expecting sort of a nice clean periodicity as this thing is cleanly spinning. If I'm driving down the road, or if my spindle starts to shake, it's out of alignment, or the bearings start to go, then I expect some vibration, some shaking, right, as manifested down there on the bottom. So a simple concept. But say I'm a manufacturer now that doesn't have the expertise to know how to take use of this data. So we apply homomorphic encryption. So we're working with, and this is an area where there are libraries that are coming out from Microsoft. There are hardware accelerators that are being developed. But homomorphic encryption, in a nutshell, allows end-to-end mathematics on encrypted data. So if I take my number 2 and I encrypt it, and I take my number 3 and I encrypt it, and I give it to Leon, who knows how to do addition, because I'm not smart enough to know how to do addition, he's going to add those 2 numbers together. He's going to get us something. He's not going to know that it's a 5. He never needed to decrypt them. He's going to give them back to me, and then I'll decrypt it and know that it's a 5. And so that is what this slide is highlighting. But it basically allows you now to never have to show your data in white space. And so the paper that we put out sort of demonstrated and developed a sort of a framework around how a small, medium enterprise can use things like homomorphic encryption to have end-to-end encrypted protection of their data. And potentially one of the business models there is to then allow an outsourcing of your data science. And this is also one of the reasons that I'll be getting back from India and then going to Japan in May to sort of do this again. So thank you, everybody. And we'll go over to the next speaker, or I guess Leon's going to introduce the next speaker. Okay, thank you.